Okay, so today's notes, 11, 16, 18, has to do with two things. One is going to be the circumcenter, and the other is the incenter. So the circumcenter is to put a circle on the outside of a triangle. Okay? Now we have to be specific, and that is when you put it on the outside of the triangle, we know that it's going to, as you put it on the outside, it's going to touch all three vertices, correct? So when you put that, it's going to connect all three vertices, okay? So if I take a look at the circumcenter down here, they didn't draw in the circle, did they? But if we were to draw in the circle, if we were to draw in the circle carefully, I mean, I'm not going to be much of an artist, but if you drew in a circle around here, then what we know about it is the fact that radii are congruent. So we know that radii are congruent. So therefore, we know that dp has to be equal to, I did it wrong. BP is congruent to PC, which is congruent to AP, because those are all three radii of the same circle. Okay, and they tell us that PA is congruent to PB, which is congruent to PC, okay? Because they are radii of the same circle, okay? And by putting the circle around, it seems really obvious, okay? Now, the incenter is a circle on the inside of the circle, right? Thank you, Landon. So it's a circle on the inside of a triangle, and these particular points are the center of those circles, right? And these are my centers of my circles. That's why it's called a circumcenter and an incenter, because that becomes the center point of my circle, right? So if I turn the page, yeah, right there, up, that way, okay? So these are the centers, these points are the centers of the circles. Either it's a circle on the outside of a triangle, or it says circle on the inside of the triangle. Thank you. As long as we know there's a circle there, it makes it easy to do. But you can see already on the book, they don't put the circle in there. But having the circle in there makes it pretty easy to understand, right? Okay, so turn the page when you're ready. I'll wait for you. Of the triangle, yeah. I almost wrote circle, but Landon helped me out. Thanks, Landon. Okay, turn the page.
Wait, it's the same thing.
Except for one's on the outside, one's on the inside. Circumcenter's on the outside, and then incenter is on the inside. Circle inside, circle on the outside, okay? All right, turn the page. Here we go. So, here we go. Now they're talking about an incenter. So we need to put a circle. We need to put a circle inside, right? And again, the book doesn't draw the circle, but if I were to draw it lightly, just kind of get an idea, the circle would look something like this, right? And I am not an artist, but, got the general idea, okay? So this is my circle on the inside, right? And once we draw our circle, then you can see that these segments here have to be equal because they're radii of the circle. So DP, PE, and PI, PF are radii of the circle. And if that's the case, they absolutely have to be equal. Not only are they equal, but they're also perpendicular to the triangle. So, as long as we know that, the problems are pretty easy. Okay, and I'll wait for you to get that written down. And I'd like to do a couple of these problems, then we'll do some homework, okay? So right at the bat, slide it up. Okay, you ready for number one? So what we have is an incenter, right? And again, I don't need to draw my circle on the inside, but I will. And so ND, that's here. ND is 2x minus 5, right? And E is a negative 2x minus 7. So I know that the two segments have to be equal because they're radii of the same circle, right? So I'm going to go ahead and solve that. I'll say, okay, 2x minus 5 is equal to a negative 2x plus 7. And what I'll do is just solve for x. Okay, so plus 2x, right? I'll get a 4x minus 5 equals 7, right? Plus 5, 4 equals 12. Divide by 4, x is 3. But that is not the answer. Plug it in because we want to find NF. So if I want to find NF, we just plug it in. So if I go 2 times my 3 minus 5, 6 minus 1, it is 1. Nice job, Landon. NF is 1.
What did we plug it into?
Great question. I was hoping somebody asked that. Because you know what? They wanted NF, but we don't have any information about NF, right? But these two are also equal to NF. So I plugged it into either one, Zoe.
How do we know they're equal though?
Great question. Aren't they all radii of the same circle?
I know, but how do we know to make the circle?
How do we know to make the circle?
Yeah.
In center. Put the circle on the inside.
So whenever it says in center, we just automatically know that the sides are the same.
Right.
So you don't even have to draw.
No.
So why are we doing circle?
That's what the book says. I draw the circle so kids don't get confused. Okay. All right. Let's scoot on over then to number 4. Okay. 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 So, on number 4, if we have equal, okay? Sure looks like this line got cut in half at 90. Sure looks to me like this line segment, or this side got cut in half at 90. And this side got cut in half at 90. So then these are going to be perpendicular bisectors, aren't they?
Yeah.
So if I look at my notes, perpendicular bisectors drew a circumcenter, right? So I know that I could put a circle on the outside, and Lana, you're right, I don't have to, but I'm going to anyway. If I put a circle on the outside, because it is, point F is a circumcenter. So point F is a circumcenter, okay? Point P. Therefore, I know that this radius is equal to this radius, which is equal to this radius, right?
This makes so much sense.
So then I know that PA, it's got to be 13, right? Doesn't it? It's got to be 13 because they're all rated the same side. So PA is 13. Thumbs up? Now, one last problem I want to do, and we'll be done, okay? I want to go to number 8, and I'll be finished, okay? Now, let's go ahead and graph 6, 4. Okay, I'm going to put my axes here just because I know where the points are going to go. And how about right about there, okay? All right. And I'm going to graph my points. I'm going to go negative 2, negative 2. There's point A. Negative 2, 1, 2, 3, 4. There's B. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. There's C. Okay, I'm going to connect my dots. Okay, connect my dots. Okay. It is a right triangle. That's going to make this easy to do. Okay. How am I doing? Okay, draw it in. Now, key word, circumcenter. Okay, circumcenter. So look at my notes. My notes say to do perpendicular bisectors. Okay, circumcenter, perpendicular bisector. Oops, you can't see that. I'm going to do perpendicular bisectors for my notes, right? So, let's take the easy one. Let's take this BC, and let's find the middle. Well, that's easy. I'm going to count. 1, 2, 3, 4, 5, 6, 7, 8. I need half of that. 4. So I'm going to go ahead and go to 1, 2, 3, 4. There's the middle of that. And at 90 degrees, right? Okay. Perpendicular bisector. Let's find the middle of AB. Let's count. 1, 2, 3, 4, 5, 6. Take half of that as 3, so 1, 2, 3, and there it is, okay? And now the middle of AC, and I want everybody to watch. I want everybody to watch. This is going to be a nice, handy trick that you're going to like, okay? Everybody watch. So to get from A to C, I'm going to go 1, watching?
Yeah.
Get from A to C, I'm going to go, I'll take a journey, okay? I'm going to go 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. Half the journey. 8, 6. Half the journey. Half the journey. Because we want a midpoint. Instead of over 8, up 6, half the journey would take us to the midpoint. So let's go over 1, 2, 3, 4. 1, 2, 3. And at 90 degrees, it's going to look something like this. So what's the coordinate of our circumcenter? It's at the point 1, 2, 1. That is my circumcenter. No, I think it's 2, 1, isn't it? See my blue?
You're right.
Okay, that's all I have. I've got some homework for you to